Hi everyone! The first movie I made on matter didn't go through and it got rejected, so here's my second take at it. Matter is basically anything that has mass and takes up space, and pretty much anything around you is considered matter for the most part, and you could separate it into two different categories: pure substance and mixture. So everything around you can be, for the most part, classified into two categories. Is it a pure substance? Is it a mixture? If it's a pure substance, then it can be classified as an element, compound, or molecule. So let's start with that first. A pure substance is a substance that is the same throughout. It's very consistent. So all the elements on the periodic table, for example, copper, when you cut it in half, is made up of copper atoms. It's all the same throughout. A compound is something like water. It has two hydrogens and one oxygen bonded. And when you look at a sample of water, it is consistently H2O, H2O, H2O all throughout. So a compound is also a pure substance. A molecule is very similar to a compound. So in order for you to understand the difference between a compound and a molecule, it's really important you write the definition down. They sound very much the same. So let's take a look at these two definitions, compound and molecule. A compound is two or more different, notice I'm underlining different, atoms bonded together. So for example, I have Na, which is a different element bonded to Cl. A molecule is two or more atoms that are either the same or different. You should circle these in your notes. So look, I put the same example as seen over here in compound because these two definitions have something in common. It's atoms bonded together that can be different. Okay, so this still qualifies right here as a molecule, but it's also a compound. How is a molecule different than a compound? Because a molecule can also have atoms that are the same being bonded together. So here's an example of nitrogen being bonded to nitrogen. The same. Nitrogen is the same as nitrogen. So therefore, it's a molecule. It can't be a compound because a compound's definition doesn't have the word same written in it. Now, if you remember from our slide earlier, we also said there's another type of matter called a mixture. And if you see here, there's two types of mixtures. But what is a mixture? That's important to make sure you write down. A mixture is when you actually add together a bunch of different things and they don't bond together. So like for example, if I just threw in, I don't know, a paper clip with a binder clip, a pencil, all in a bowl, that's a mixture. If I threw oil in a cup full of water, that's a mixture. Some things mix really well and other things don't. It doesn't matter. As long as the things that you add in don't bond together, it's a mixture. So there are two types of mixtures, and those are heterogeneous and homogeneous. So now that we're done talking about the two different types of matter, let's look at some pictures. Here are the first type of matter that we talked about, pure substances. Elements, compounds, and molecules, if you remember, are pure substances. So the first picture shows a picture of elements, and if you look, they kind of look like just copper atoms all lined up by each other. They're just single atoms of the same substance. And then if you notice, here are some examples of compounds. Notice at least some of the stuff bonded are different. Got some different colors showing for different bonding, right? Two or more atoms bond together, and the atoms that are bonding together are different. And then we have molecules down here. And if you notice molecules, some molecules are also compounds. Look at all these. These are all compounds, right? Different atoms being bonded together. Notice the different colors. I've got blue and orange. That's two or more bonding together. So that's a molecule and a compound. So how does a molecule and compound differ? Well, look at the top line here. Molecules can also have two of the same things bonded together. H2, O2, N2, Cl2, but compounds can't. Here are the two definitions of mixtures. So there's heterogeneous mixtures and homogeneous mixtures. A heterogeneous mixture is a mixture that when the things were mixed together, they didn't mix really well. So the mixture has different compositions, different properties, meaning it looks a little different in some areas than others, like oil and water. And so the appearance throughout the whole mixture has somewhat different parts. That's what hetero means, different parts. I always like to say heterogeneous mixtures do not mix well. Heterogeneous mixtures do not mix well. Like sand, when you add it to water, the sand just sits at the bottom of the water. It's still a mixture, but it didn't look the same throughout. It has different parts, the sand on the bottom, the water on the top. Homogeneous mixture are mixtures that are mixed really well. And because they're mixed so well, they look the same throughout. They're pretty uniform throughout. And that's what the prefix homo means. Homo means the same. So like, for example, the air you breathe in. So look around you, breathe it in. Now go to the other side of the room, look at it, breathe it in. Air is a mixture of all different gases, N2, O2, hydrogen, carbon dioxide, but you can't tell because it's mixed very well. You don't hear it, smell it, see it. There's no difference. So it's a homogeneous mixture.